Well, welcome to this MBS presentation on holistic specification of materials. My name is Paul Swaddle, and I'm Head of Technical Solutions at MBS. Just a couple of bits of brief housekeeping before we start. The webinar should last approximately an hour, and to avoid sound issues, your microphones will be muted throughout the session. But if you do have any questions or comments, you can fill those in the question box to the right-hand side of your screen. We'll try to pick up as many as we can, and then we'll follow up with some of those responses afterwards. I'm delighted to be joined today by Taleen Josefsson, Thrive Project Manager, who's going to talk through some of the work of Chetwoods Thrive, and in particular, their industry-leading material consideration strategy. I've been consistently impressed by Chetwoods Thrive ever since first discovering their work and meeting the team, so I'm particularly looking forward to hearing from Taleen today. So Taleen is going to consider how design teams can achieve health and sustainability goals with better informed material selection and how they go about accessing that environmental performance data. After Taleen's presented, there's an opportunity for some Q&A time, responding to the content, and then I'm going to take a look at how sustainability and that holistic specification has influenced MBS content, and in particular, how we're working with manufacturers to respond to the issues discussed in the webinar. So I'll hand over to Taleen to start.
Welcome to the holistic specification of materials, achieving health and sustainability goals through informed material selection. I am Taleen Josefsson, registered architect in the US and Sweden, certified Passive House consultant and a project leader at Chetwoods Thrive. I'm one of 4 on the Thrive team making sustainability simple for developer, clients, and property professionals. We support in the design and delivery of our quality architecture that improves our health and enhances our environment. During this session, we will be covering a number of topics. We will discuss the broad context of global and national UK sustainability goals and how they apply to building design, construction, use, and end of life. Design drivers for healthy, sustainable buildings. Material resources, which I consider to be architectural building blocks. The essential role of material selection in achieving the commitments and goals. The tracking of material and resource data, including the use of material passports, healthy materials, and material data references. And finally, we will discuss the tools, including the resource decision hierarchy used by Thrive in specification decisions. A brief introduction to Chetwoods. Chetwoods inspire through imagination, pushing the possibilities of design for living to help people and planet. We use rigorous thinking and radical creativity to explore the boundaries of architecture. We're brave, bold, and ready to challenge the status quo in our ideas, in our processes, in the materials we use, and the levels of well-being we can achieve in the built environment and beyond. We never do gray. Our offices are located in London, Birmingham, and Hamburg, Germany. The Chetwoods brand has 3 key elements: Studio, Works, and Thrive. These components inspire, support, and complement each other. The grand concepts and imaginative leaps emanate from our studio. Amongst a variety of notable projects, Studio has delivered the Chelsea Gardens project, perfume, and interior objects designs. Works finds the best ways of transforming concepts and ideas into actuality. It champions the digital delivery of projects and provides support to the teams in the use of innovative software and hardware to deliver sustainable architecture with a measurable positive impact on human well-being and the environment. The Works team is currently working on digital twins. Thrive contributes to its pioneering thinking on enhancing our environment while improving our health and well-being. We provide solutions to the climate emergency that can enable us to thrive. When Thrive was founded over 2 years ago, the Bay Tree Tech Hub was the first project we were involved in. The client wanted everything in the building to tell a story, and we took this opportunity to apply circular design principles to the construction. This tech hub can then be deployed from one site to another by the client. The Bay Tree Tech Hub won a Business Green Award and was nominated for the AJ100 Best Use of Technology Awards. It was designed as a marketing hub that housed a BIM cave where clients could go in and see the virtual model and select their finishes to avoid Category B finishing waste. In the images, you can see a selection of furnishings and finishes where great care was taken to select low energy, recycled, and reclaimed materials for the temporary buildings' interiors to reduce the overall climate impact. For example, the floors were left unfinished, save for a sealant finish. We chose reclaimed table legs from another office. The chairs were 100% post-consumer waste that can be sold back to the manufacturer in the end. To give an overview of the current global and national context, a brief timeline shows major events relating to sustainable goals and commitments made in recent and coming decades. In 1987, the Brundtland Report, which drew attention to the climate emergency and developed the most widely used definition of sustainable development as development which meets the needs of current generations without compromising the ability of future generations to meet their own needs. What then followed was decades of inaction despite awareness of climate change through further commitments. In 2002, Cradle to Cradle by Michael Braungart and William McDonough was published, introducing the ideas of regenerative design, where materials are viewed as nutrients circulating continuously in healthy metabolisms. This was followed by the launch of Ellen MacArthur Foundation in 2010, based around the concept of circular economy in response to the sailor, Ellen MacArthur's shocking realization of the plastic pollution crisis she encountered in her travels. In 2016, the Paris Agreement was signed and went into effect, along with the UN 2030 Sustainable Development Goals. In 2017, Donut Economics was published by Kate Breworth. The UK declared a climate emergency in 2019 and is legally bound to deliver a net zero carbon Britain by 2050. In order to deliver this, all new buildings must be net zero carbon by 2030, and all existing building stock must be net zero carbon by 2050. This actually means that the UK should be retrofitting 1,000 homes a day starting in 2020 to meet this goal. From the emergency declaration, we saw the formation of LEDI, Architects Declare, and ACAN. Resulting from this, the UK brought forward their UK definition for zero carbon. In 2019, the REBA 2030 Challenge was released. In parallel, we saw UK guidance come out, including the UK GBC framework for sustainable building, alongside the guidance from LEDI and ACAN. And the UK Environmental Bill, created in 2018, has yet to be signed into law. The planned legislation includes a legally binding biodiversity increase by 10%. This is our current status, and we don't have much time to implement drastic changes to meet the goals and commitments made. So let me share with you a few relevant statistics. 49% of the UK's greenhouse gas emissions are linked to construction and operation of its built environment. 11% of global greenhouse gas emissions are attributable to the embodied carbon of buildings and construction. And 90% of a building's environmental impact is defined by the very earliest design decisions, including building location, orientation, massing, form factor, window placement, etc. These frightening statistics demonstrating the built environment's massive impact on the Earth, as well as the role that the designer plays in determining an individual building's impact, is the origin of Thrive. Based on the UN Sustainable Development Goals, we have come up with our 7 Thrive drivers, which we use to review our buildings against. We think these are the themes most relevant to design and architecture. These 7 drivers are carbon control, water, resources, health and well-being, resilience, biodiversity, and value and cost. Today, our focus in this talk is going to be on resources, the materials we use in our buildings. The end result of our work as architects is a building, and the building cannot exist without the sum of its materials. Therefore, the material resources are the architectural building blocks. At Thrive, we see 2 areas of advocacy in building. Stage 1, where we can assist with the brief, and the second area of advocacy is at the specification stage. Architects have been burned by value engineering time and time again, but we believe that with better, more robust interrogations to highlight the value added in the materials, we can lock them into the specification. This diagram shows the circulation of materials and some of the impacts of physical resources on the building and its inhabitants. Materials directly impact the building's embodied carbon. They impact water usage. There are limited freshwater resources, and only 1% of water is fit for human consumption. Material chemical makeup directly impacts both human and environmental health. You can see some of these resources going into our building diagram here, as well as the circulation of materials through use and post-use, which should be continuous. So just to re-emphasize, the purpose of specifying reused, refurbished, bio-based, or recyclable materials is the following: reduce emissions now, preserve resources for the future, prevent or minimize future emissions and waste, and provide healthy environments for people and nature. At a population of almost 8 billion, we are already consuming 1.7 Earth's worth of resources per year. In order to reduce emissions and support a growing population, there is a need to consider the life cycle of products. We must ensure the full value of the product, keeping it in circulation for as long as possible. Across all projects, we apply circular economy principles, referring to the 6 R's. This is the resource selection hierarchy in order of the best to least desirable choices. Reduce the project brief or scope, including unnecessary materials and high embodied energy materials. Question if a new building or construction is really required. Retain existing buildings and materials if working with an existing building. Reuse materials and components as much as possible from local suppliers, including repair, refurbishment, and repurposing. Recycle, rot, and finally reject toxic and unethical products, refuse and dispose of hazardous and unhealthy materials. If having to choose new materials, ensure they have recycled content or are natural/biodegradable. The 6 R's have been developed at Thrive as a building-specific choice hierarchy based on the Ellen MacArthur Foundation Circular Economy Diagram. In order to create our selection hierarchy, we drew upon these tools that are prevalent in the industry. On the left, we can see the well-known Circular Economy Resource Circulation Diagram by the Ellen MacArthur Foundation. The 3 main takeaways from this are: design out waste and pollution, keep products and materials in use, and regenerate natural systems. One point which we would like to highlight is the separation of bio-based and technological materials, as seen in the separate diagram loops in green and blue. When you create material composites by mixing bio-based and non-natural materials together, such as in textiles or trainers, they create a monstrous hybrid, a term used by McDonough and Brongard in their seminal book, Cradle to Cradle. Such a mixture is nearly impossible to remanufacture or reprocess. It's like trying to unscramble an omelet. Most often, these products end up in landfill and at the end of their useful lives. On the right, we have a table from the UK GBC Circular Economy Guidance. This table is based on the lifespan categorizations for the R's, maintaining the value of materials for as long as possible. Length of life planning for certain materials is crucial for determining design and material selection strategy. For short life components, 0 to 5 and 5 to 10 years, the overall strategy is to design for disassembly and return to manufacturer or design for reconfiguration using modular systems. In long life component planning, 20 to 30 years, the overall strategy is to design for maintenance, replaceability, and remanufacture. In even longer life component planning, 30 to 300 years, adaptability is the primary focus. Tracking material data. Looking beyond high-level material selection strategies, in order to ensure that the individual materials we select are meeting the goals laid out, we need to be able to track robust material and product data using tools like material passports. Material passports should provide a wide variety of in-depth information about the materials. To mention a few, they should contain material origin, typical applications, certifications, chemical makeup, embodied carbon, water usage, and expected lifespan, amongst a great deal of other data. This information should be provided by the manufacturer. If it is not immediately available, designers and specifiers should take the time to inquire about more information. Transparency is key. To the right, we have some good material declaration examples. These are tools in progress, some of which are not available to everyone at this time, but they are getting there. The top left image here is the Medaster platform from the Netherlands, which has a database of registered materials and can provide material passports from within their software alongside BIM integration. Below that, you can see a declare label associated with the Living Future Institute, which focuses on the material impact on health and well-being and is modeled after food labels. The top right image shows the documentation of a reclaimed material from the EU project FCRBE. And the bottom right is a screenshot from the Materials Passport platform prototype by the EU project BAM, known as Building as Material Banks. While we're waiting for the tools to become more developed and standardized, we at Thrive have done our own analysis of the materials we specify regularly, including asking additional hard questions to the manufacturers, pushing them for cradle-to-cradle information. From this, we have created our own internal material passports organized by building layer. The building layers are shown in the shearing layers diagram to the left, originally developed by Stuart Brand in 1994. The basic concept is that the various layers of the building, the site, structure, skin, services, space plan, and stuff, all have different expected lifetimes, depending on wear and tear, aging, and replacement based on cultural factors. The longer-lasting, more robust layers of the building, such as the skin and structure, have the greatest environmental impacts and stay in use the longest. By collecting material data such as the material embodied energy, chemical content, etc., it provides a greater case to include materials we specify in buildings and serves as a better comparison tool. We drew on the Buildings as Material Banks project guidance and added our own additional criteria. We've used the material passports as a tool for a conversation point with the MBS to improve search functions and incorporate a broader range of material data in MBS Source. Material passports are just the first step. Drawing upon our 6 R's, we know that using virgin materials is not the best option. In many cases, material passports focus on new materials designed for reuse at some point in the future. We should look to materials already in circulation, such as those found in the existing building cadastre, thereby reducing further emissions and demand for virgin materials. At the moment, a crucial barrier for existing material reuse is the lack of data easily available. As materials from existing buildings are salvaged at the end of their first life, we need to collect the appropriate data through material testing, followed by the amalgamation of that data in material passports. Secondly, we need to ensure that the material passport information is passed on to the end user so that it actually gets reused. Material passport data integrated into BIM models can help track these new and reused materials and components in existing and new construction. With this link, each item can easily be identified with the associated material characteristics integrated in the software, making tracking materials in buildings in use a breeze. As architects, we need integrated workflows. Material data must easily be available to us at all stages of the design process. BIM integrated material tools help to inform embodied and operational carbon, circularity metrics for early stage analysis through to stage 4, aiding the architects in making fully informed design decisions at all stages of work. At Chetwoods, our works team is currently developing digital tools as a way to carry materials information from the design through to operations and post-occupancy and component or building end of life. Maintaining these digital twins aids in tracking the materials and components installed in the building, carrying the material data and history through to the end user, so materials can be continuously tracked and actually become salvaged and reused at the end of their first useful lives. To the right is an example of a digital twin project, the Sainsbury Digital Lab, designed and maintained by Chetwoods Works. While not applied in this example, BIM integrated tools are needed to bridge the gap between connecting material and resource data to digital models, which we hope can be streamlined with the MBS. Sustainability should be a primary focus to meet the current climate and biodiversity crises. A few concrete steps going forward include update physical and digital material libraries with the data that supports architects in making the best decisions for sustainable and healthy buildings. A part of this is needing to interrogate our materials harder and ask questions to encourage material manufacturers to be transparent. Let's avoid using the same materials again and again that we know are not healthy or sustainable. Architects should look into new ways for advocating for the client and the end user to ensure materials are better understood by all parties along the value chain, avoiding unnecessary waste. And by applying our selection hierarchy, reduce, retain, reuse, recycle, rot, reject. When looking at buildings and materials, we can ensure that we are minimizing waste as much as possible. When it comes to material considerations in construction, taking proactive steps to specify healthy and sustainable materials in our buildings will help us drastically reduce the building's environmental impact and move towards achieving our targets, like the REBA 2030 Challenge and the UN Sustainable Development Goals. And most of all, let's avoid monstrous hybrids. Thank you for your attention. We will provide the resource links in the webinar information. If you have any questions or would like to discuss the topic of material selection with us further, please reach out to us using my contact details provided here.
Thanks so much, Taleen, and thanks for joining us for this part. I just thought it'd be useful to go through some of the questions that definitely have arisen as a result of your webinar, and to think about some of the aspects of what you talked about. I thought one place that would be a good one to start is, what do you define as a holistic approach? Because we've titled this webinar Holistic Specification of Materials, but can you provide a bit more information on what a holistic approach is to you?
Of course. I think that is the approach that I describe my thinking about architecture and sustainability the most is holistic. For me, the holistic approach means utilizing systems thinking and making decisions where everything is connected, and architectural design decisions can impact not only the immediate users of a building, but also has social value and economic impacts along the entire value chain. So I define systems thinking, and this is kind of taken from my literary studies in my master's program, as an instrument of rationality that can expose or explain how things are connected and the nature of their connections. It's a useful tool for designers to understand complex issues, and those can range from anything relating to the built environment, architectural design, material choices, social value along the value chain, a variety of factors. And if you're not familiar with the concept, I will actually be doing an architecture-focused virtual workshop with the MadCon on February 19th, in case anyone is interested in that. But generally, I think holistic, or the term holistic, when talking about sustainability is a better term than sustainability, because I find that sustainability is quite an overused term, and it's kind of lost its meaning in being overused and kind of being applied to greenwashing time and time again. Because it's not just about slapping PV panels and green roofs on a building, which sometimes people, that's their approach. Instead, what I try to do, and I guess what we're trying to do at Thrive, is actually about designing with the passive principles, aka stealthy sustainability, and healthy materials at the start of the project, like I mentioned in the talk, where that's where we hope our 7 drivers will come in and cover all areas of sustainability. But I actually also run an Instagram called The Holistic Architect, where I try to bring to light all these sustainability issues, whether it's building related or good human behavior, like day-to-day life behavior. So that's it.
I think it's brilliant. And I think more people should have an awareness of systems thinking in their general approach to all kinds of subjects. It leads neatly onto the next question, which is, sometimes those themes of sustainability, and even just that word, can seem so vast and overwhelming. Is it those Thrive drivers, or how does Chetwoods ensure that it's a guiding principle for all of your work?
I agree. Themes of sustainability can be very overwhelming, and that's why it's very useful to have a dedicated team like Thrive in-house in an architecture practice, because not only does it allow us to support our staff internally while being focused on delivering projects, but we're also, because it's a crucial part of our work, we're able to stay on top of the latest innovations in materials and technologies that we can incorporate into built projects. But I guess the common descriptor of sustainability, where it's an understanding that one does not do any harm, that's no longer sufficient. That's not a sufficient descriptor anymore. what we need to do is actively provide regenerative spaces that improve our own health, that of the natural environment and the economy. But additionally, we must take into account social justice and equity, because the well-being of all people is a crucial aspect of sustainability, not just economy or environment.
Yeah, no, that's fantastic. One of the topics that's clear that you're really passionate about is material reuse. And we've mentioned a couple of the examples shared in a previous webinar about information that can be provided to help people in that way. And in your thesis, one of the diagrams that you have is of a material sourcing diagram to allow a designer to consider materials that are in the local area, whether it might be local demolitions or sourcing of material availability. Can you talk more about that concept?
Yes, it's a concept very close to my heart. It's one of the things I'm most passionate about. So the material sourcing map that you mentioned is actually based on the example set by the Dutch firm Superuse Studios, who created the Harvest Map, which identifies maps and makes available to architects, designers, constructors, construction materials that come from demolitions and products that have reached their end of life, unsold inventory and stock components from demolished buildings and leftovers. That is available in mainland Europe, specifically Belgium, France, and the Netherlands area. But really what I think needs to be done is that every architect, or for every project, we need to look at the local area of the project and do this exercise so that we have a good understanding of what is available locally, so that we're not looking to further abroad sources, for example, ordering from other continents. So the three main aspects to consider when looking at these local source materials are, I guess, the pros. The first, which is the large portion of embodied carbon emissions, is actually embedded in the transport of materials. So by reducing transportation, especially from other continents, we're reducing the environmental impact of a product. Secondly, you're supporting the local economy through labor and production. Even if it's with reused materials, you need to have labor to carefully deconstruct the materials and then resell the materials so you have that local market available. And thirdly, and perhaps most importantly, local sourcing ties the building to local history and vernacular building styles and methods, which contributes to a sense of place and hopefully increases its attraction for the local community. And a loved and beautiful building is a sustainable building because it's well cared for over a long period of time. People want it to maintain.
Yeah, I like that definition. Yeah, that's ideal. One of the other things that you mentioned is that there's 4 key ways that the industry could move towards material reuse. We'll bring those up on screen. They're education, material audits, and an inventory of what's available at demolition, the transparency of the data that we've talked about, obviously with MBS Source and with the work that you do with your materials passports. But I guess one in particular that I'm interested in is long-termism and thinking about, the planning aspect of all of this and thinking about things for the long-term future.
Yes, those are all equally important, I think. In general, the way I came to those 4 main topics was that I performed a systems thinking exercise on my reuse materials thesis. And those were the major system interventions that I identified during that exercise, that we have so many issues, and a lot of the issues are actually symptoms of larger issues. So if we target those 4 major changes, the education, material audits, transparency, and long-term planning, they're targeting the system leverage points. And by doing so, we can incur massive change, because these 4 in turn will have massive downstream effects that will trickle into human behavior, values, architecture and construction practices, policies, political policies, and just building regulations. So I think that just focusing on those, especially the education portion, actually,
Mm.
just starting from young ages, and education that applies to not only architects and contractors, but folks that end up in those government regulating agencies and things like that, so that they're aware of the necessity to reuse resources, and that waste is not actually waste, it's a resource. Those are really important human values to kind of push along into society. But to your point about long-term planning, that's really something that architects need to include in their work process. Not designing for like a 30-year facade, not designing for a 60-year building life, to actually design components so that they can be disassembled. And that will come down to joints choice. It'll come down to materials choice. But it's truly important, and it really should be taught in architecture schools.
As an aside, you've been in academia, recently. Are you positive about what you're seeing, and that whether it's the educational institutions themselves or students and young people in architecture and design, that they are beginning to take these things seriously?
Yeah, there's so much work happening in academia. I mean, of course, work, but like social activism and environmental activism. There are so many environmental activism groups that have recently popped up in the last 1 or 2 years since the 2019 declaration of the climate crisis, just in the UK. I can't give you the number, but one example is the Anthropocene Architecture School run by Scott McCauley. He does fantastic teaching webinars virtually, but he also has his own courses that he teaches in. And students are really becoming active. It's activism is essentially what it is. They're not just focusing on their schoolwork. It's not just in projects. They're really getting involved. They're going out to marches. We saw so many students and young people and practicing architects at the 2019 the Architects Declare. No, sorry, it wasn't Architects Declare. That day in London, or it was all over the world, led by Greta Thunberg. That was fantastic to see so many people out there. Everyone's getting involved. So there's a lot of change going on.
Brilliant. Well, I think what we'll do, if it's okay by you, is to follow up this session with a bit of an article, and then some of the links that you shared at the end of your presentation, some further reading. We can put all those links in and provide that to people who are watching today.
Great. Thank you so much for having me, Paul.
Thank you. Thanks so much for being here. Really appreciate it.
Of course.
Well, okay. I thought that it would be worthwhile now looking at some of the impacts that the discussion that we've had, some of the themes that come through in sustainability have had on MBS and the content that we produce. And with that in mind, I kind of wanted to start from another event that's available. If you go to the events page on the MBS, there are webinars like this happening all of the time. And last year there was one on sustainable outcomes and the RIBA plan of work, where Michelle Lucarelli, who's our technical content QA manager, went through quite a few examples of practical examples of our content. And Gary Clark, who's a principal at HOK, provided some examples of net zero and net positive building types as well. So it's a really good webinar. And within there, Michelle brought up on screen some content examples. So I thought I'd just review a few of those and how the work of Chetwoods Thrive and other industry feedback really does influence our content. I'm going to go into MBS Chorus. And within MBS Chorus, you can have multiple projects available, depending on the ones that you're working on and you've created, or that you've been invited to work on yourself. And within here, I can show you a few examples of where performance content around environment and sustainability can be provided. So the first is thinking about preliminaries or project management content, and where you can make very high-level environmental requirements visible within the specification. So within there, you've got a number of sections for project management, and that project information, this first section, again, covering the kind of general requirements of that particular project. At the base of this, we've got a clause specifically looking at the environmental policy required for that particular project. So this could be detailing out your own specification strategy, environmental assessment schemes that you're working to, and then thinking about the compliance checking that's going to be required against those. So from that very high level aspect, we can begin to think about the environmental policies needed across the project. Equally, we can go into a little bit more detail in terms of thinking about life cycle requirements for a building. So when we get into the project performance itself, this is the kind of whole building, whole site aspects of the projects that are required. Within here, we've got the ability to define life cycle performance. So very general skeleton clause to begin with, but this is where you can begin to specify aspects like government soft landings and BISRIA guides, those kind of things. And all of these clauses are adaptable to allow you to tailor them to exactly what it is you need to specify for the projects that you're working on. Equally, within this list as well, a bit further down, we've got aspects in terms of relating to specific environmental performance criteria. So in this case, you could be working to BREEAM as a scheme. You can open up this clause and then begin to define the levels of required performance and ratings at each stage. So that at design stage, setting out the criteria and then putting in which BREEAM scheme, refurbishment, whatever it might be that you're working to in this. And again, adapting those clauses to define criteria for environmental performance right at the beginning of the project, and to carry those project management requirements all the way through. Then we kind of move into the idea of systems and products, which is where the MBS content really comes into its own. And we think about the development of specific criteria against particular building types and particular projects. So within a particular set of information in our specification, there's a number of examples where environmental performance is really critical and where we're beginning to really learn from how sustainability is specified in practice. So that can go from something at the most high level in terms of setting out key system performance criteria, so defining the properties of a particular system, its U value, the energy ratings, air permeability, and so on that are required, and then all of the components that make up that particular system and how they begin to define that specific performance. But within here, you can imagine the kind of calculations and measurements and specific values that you need to define within here. Against all of these clauses, there's a huge amount of guidance content available as well, helping you find those links off to the standards and ISOs that are required for these calculations and for these assessments, and then to different reports and guidance and technical information as well. Equally, we've got a number of systems that relate specifically to thinking about sustainability criteria. So whether it's ground source heat pumps, again, thinking about the specific aspects of design decisions that you're making on what type of systems to use, there's guidance to help you make those choices and to make good selections about which ones have the most environmental impact and which ones are going to help you to meet those sustainability criteria on your projects. Equally, there's aspects in terms of things like sustainable drainage, so swales here, and equally information from Syria and SUDS manuals and so on in terms of water. And all of this are kind of aligning with those RIBA sustainable outcomes and certainly the Thrive drivers that we've seen as well, thinking about the type of information that you might be specifying. But the broadness of MBS Chorus and certainly of Uniclass 2015 in terms of providing that kind of information, right from power and energy all the way through to water management, and even into things like the specifics in terms of thinking about sustainable aspects of life and sustainable aspects of your project. We can define cycle parking equipment, we can define the materials that are going to be used and start to define their working life, and thinking about how they can be accessible, suitable for children, and so on. So all of those aspects can be specified within the content. Equally, we've got content for reclamation and certainly material reuse, which we'll come on to a bit more in detail. But being able to add in your own information in terms of where this material is being found and the criteria of how to check and verify its suitability for its condition and how it's actually going to be installed. We're also trying to develop sustainable content in terms of thinking about the information that we've got within our specifications and some of the systems that you may be choosing, and trying to make that job easier, where you're actually finding systems that improve the sustainability and environmental performance of your projects. The last aspect to have a look at is in terms of the activities as well. So as well as the systems and products tables of Uniclass, we've got MBS Chorus also supports the activities table, and that's type of things like demolition, surveying, conservation aspects of a project, which maybe otherwise it would be difficult to specify. And one of those is timber sourcing. So in this case, we can provide an activities clause for exactly how that timber is going to be sourced, whether it's general requirements about how well managed the source is, or working to specific certification schemes. And again, guidance on the right-hand side to help you make those choices and find that kind of information. Each one of these is a hyperlink that'll take you off to those websites, and then you can begin to specify based on those specific criteria. Again, evidencing that and providing that verification as well. And so I then thought we'd take a look at MBS Source. So as Taleen mentioned, specifically, we've worked in terms of thinking about those materials passports and how this information can be better surfaced in terms of MBS Source and our product information. So our database of product information, being able to find manufacturer data wherever you need it and in the context of your projects. And so if I search here for carpet, you can imagine that there's a huge amount of criteria we could sort these on, in terms of their third-party certifications. We might have a particular manufacturer in mind, whether they've got digital objects available, their size and shape, but especially things like now their recyclability and also their embodied carbon statistics that are now provided by some of those manufacturers. So we're now working with manufacturers to begin to fill in some of that detail. And again, against the detail of the materials passports, we may not have all of that information, but we're beginning to develop some of it. So this one, in terms of having an embodied carbon calculation, whether it has any red listed materials and its country of origin and where that's coming from, along with typically recycled content and recyclability. When we begin to think about the materials passport and the criteria against those, as I mentioned, as Taleen's shown, there are many of these things that we do have already, and we're beginning to add in. Certainly in terms of the building product properties, in terms of how that product can be used within a project, that's where manufacturers tend to provide the majority of their information. And it may be a completely different team that's responsible for thinking about things like the embodied carbon calculations. So we're beginning to work with manufacturers to understand how we improve that data and how we fill in more of that information. And there's a couple of good examples here as well. So here's one from Oscar Acoustics. And if we jump to that specification data, we can begin to sort of enhance the information that's available there. And in this case, we've got manufacturer and origin information. We've got some understanding about the embodied carbon, but also whether the emissions, VOCs, those kind of things are in league with particular environmental standards and policies, and all of the typical properties that you would expect to be there as well. And so a lot of those manufacturers are beginning to demonstrate a greater understanding of the properties of their products, and equally being able to then compare those against other manufacturers. So this being a Saint-Gobain Ecofon item, and they're now declaring, that all of their products are free of red list materials of very high concern, and the compounds on the REACH list as well. And they're also beginning to define their embodied carbon against a particular standard, so that we have some understanding of how those are being calculated and being able to compare those along with things like the country of origin. So we'll continue to work with manufacturers and develop those aspects of their information in tandem with organizations like Chetwoods and Chetwoods Thrive to help us develop that information. Well, thank you so much again to Taleen for her time today, and we hope you've really enjoyed this webinar. We'd love you all to start using MBS Chorus and MBS Source successfully, and our teams will be in touch with anyone who's attended today to follow up and try and answer some of those questions that you may have put into the chat. But do contact us if you'd like any further information on the details below. We look forward to seeing you at the next webinar. Thank you.